Alright, so here we go with our first of, I think two of them I'm not going to be able to work on, so I guess one of five. It may end up being more, I don't know, we'll see. We'll start with the first one here. And just giving it a look over from a little bit more than I did before off camera now. R104 is smashed flat. There we go. And C57 here is all wobbly and wonky. And if we look at the back of the, we got a lifted pad somewhat. It's right here. I don't know if you can see it wobbling there. So I don't know if that trace is any good. Seems to be okay though. And I mean, someone put D18. Someone's done a lot of this work. Now I assume it was working. We're gonna assume that it was working with all this stuff on here done like this, and then we're gonna assume it was working with that stuff on here. So we're gonna leave it. So what I'm gonna do is go through. It says, let's see here. The note that's on here is. Let's get rid of it. It says 4-player X-Men. I believe playing blind. I believe 4-player X-Men playing blind. So I imagine that means there's no power. So I'll save this to put it back on there when we're done. But I do have a flyback and a cap kit. We're definitely going to need the cap kit because they've got substandard caps in here. This one's been changed. It's all wobbly. This one's been changed. It's all wobbly. These are all original. I can tell from just looking at it. So this is quite the ordeal. The H position jumper is missing, which doesn't matter because the center pin here, there's a left to the center and a right. When it's hooked up to the center, it's a dead contact. So having it hooked up to the center is like not having one hooked up at all. So it's okay unless you wanted to hook up to shift it left or right. That's all that is. And also the ground wire that hooks, the DAG wire that hooks to the tube frame is missing. You can see that the wires are broken off. The wires are busted off here and it's missing. So I'm going to install my own when the time comes. I got another wire here. So I mean it's complete except for the DAG wire missing from the neck board and the jumper for the H position. Otherwise it's complete, and not only is it complete, it's got extra parts on it. So we're going to assume that it was working with those extra parts, and like I say, D18 is normally supposed to be right down in here. Right there is where D18 is supposed to be. Looks like somebody has snipped it out of there and put it on this side. It's normally supposed to be this contact here and this contact and it right here across this way. But this is the same trace, so it's okay to have it there. But why this is here, I can't tell you. Why it's on the back side, I can't tell you. So we're going to assume it was working with all this stuff the way that it is, and then it just stopped working. So we're going to test all the components, and we'll see what we can figure out here. Alright, so most likely the flyback went out and took something else out, but we'll find that out here very shortly. I have my desoldering gun and my fan going, so if it's hard to hear me, I apologize. So we'll start with our diodes in our power circuit here, our bridge rectifier diodes. Of course, we're looking for 0.5 something. D19, 0.48 is fine. D20, D21, D22, D24, and D23. Alright, so those are all good. We can check R104. Was it supposed to be 15 ohms? That's good. R103 should be 2 ohms if I'm not mistaken. 2.7, so it should be 3 ohms. Again, you can go to the top connection, and then you can either go to, I just go in here. You can see inside here there's the other leg right here that goes down through to right here. So it's up to you. We can just do it this way. 3.2 ohms. So R103 is good. let's back up a bit. I always go the wrong way. Alright, so our power diodes are good, R104, R103. We can test our HOT. The HOT is here and here. HOT is good. That's a completely normal reading, 0.5 across the base and the collector and emitter. Okay, then we can check R89. That should be 3.9K. Close enough. We can check R97, 270 ohms. That's good. R96. That's good. I guess we'll check D18. D18 is good. We can check our critical safety cap, which should be like a diode across diagonal. Yeah, and yeah, critical safety cap is good. C30, that was C38. I'm sorry, C36 is critical safety. C38 is the width cap, but for some reason they got this jury-rig deal with two caps together. I've never seen that before. So that would equate to, what is going on here? This is, okay, that would equate to here, and it is not shorted. That's all we're looking for on that C38 is to make sure it's not shorted. It's not. Voltage regulator, again, this has the STR3130 with the 4 pins, not the 5. And on this case, you want to go to pins 1 and 4. And the easiest way to do that, to make sure it's not shorted, is to just go to your B plus resistor. This should be, what, 200 and, I think it's 200 something ohms, 180, somewhere around 200. Yeah, 170, so that's okay. So our voltage regulator is not shorted. Again, you can always go to the diode checker. I think you can go across 1 and 4. Maybe it's the other way. Well, that's interesting. That's much lower than it should be, 0.1. It should be 0.5. So we've got our 180 ohms on our B plus resistor, so it's not shorted, but it could be open because that is not a correct reading. Yeah, see, that should be like 0.5 like any other diode internal to the voltage regulator. Yeah, and if you look at the wires, you can see that it goes to pins 1 and 4. The red wire goes to pin 1. It's right here on this same trace. And the blue wire goes to pin 4 on. So when you go to across 1 and 4, that should be your diode. On the other style, it's pins 3 and 4. On this style, it's 1 and 4. But that's not a correct reading. So I bet you we have a bad voltage regulator. So what we'll do is we'll test it. Well, you know, I don't know if I want to test it. Let's replace the voltage regulator, because the thing says playing blind, the notes, so I assume it doesn't work. So let's replace the voltage regulator. Maybe something arced and touched, I don't know. Everything tests good. We don't have a shorted critical safety cap or width cap or R103 or bad diodes, or we don't have, did I mention HOT? No, HOT is good. So unless the flyback is bad and it took out the voltage regulator, I can't say. Usually if the voltage regulator goes and the flyback goes, it'll short the fuse. Fuse is good. Let's reseat it. Just looks kind of dingy and dirty here. Let's clean off a little bit and put it back in. Alright. So let's change the voltage regulator out. Let's see what we get. Alright, HOTs. Here we are. We got plenty of them. And I guess I'll go ahead and change the flyback because not only is this the white knob version, but it's got a big crack across it. There you go, you can see a crack across there, crack across there. So if it's not arcing now, it soon will be. So we'll change the voltage regulator and we'll change the flyback, and then we'll see if it works, then we'll do the caps after that. Right. So these were my this one, that one, and that one are my counterfeit ones. I'm holding on to them, but I have 1, 2, 3, 4. I got 4 of the correct ones. And what I mean by counterfeit, if you haven't seen my other video, you can see the difference in the stamp on here. You can see how this one over here looks like it's been inked on. This one over here has been properly done. And I'll bet you, if we were to take some alcohol, I bet that would come right off. Let's see. Yeah. Oh, these damn counterfeit assholes, man. See that? That's coming off of there. That shouldn't be like that. So these are counterfeit, and I'll show you here on the meter. Okay, pins 1 and 4 are what's supposed to be the diode. And if you see here, if we go to the counterfeit one, if I go to cross 1 and 4, nothing. We'll try it the other way. Nothing. Now if I take the correct one here, I go to 1 and 4. Oh, I'm a complete moron. Sorry. Let's go back one step. Click. There we go. Okay. 1 and 4. 0.935. You don't even hear it beep. The other way it shows nothing. And I go back across this way. Yeah, that's no good. Now if we go to the correct one, the one that's I have no doubt about, let me go to 1 and 4. There's our diode, 0.575. You can hear it. So, yeah. These ones here are good. I've got 4 of them. All 3 of these are counterfeit. We already tested the one. You can see here how much the alcohol took off the silk screen there. So if you ever have a suspicion of your parts being counterfeit, you can always take some alcohol, and if you can get rid of the stamp, it's counterfeit. I could scrub all day long and it won't come off of this one. But we already know this one's no good. So if we test these again, wrong, wrong, good, 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 good. So, yeah. These are no good. But I just like to keep these on hand for show and tell like that, so I'm going to hang on to them for now. But I'll take one of these and install it. And we'll see what the reading is afterward. We know prior here that our reading is across 1 and 4 is only that should be 0.575, like this. That's what it should read in circuit 2. So I think our flyback took out our voltage regulator, so let's take the voltage regulator out, change it, and then we'll also change the flyback, and then we'll see if it works. You know, I mean, I might as well just do the caps too. I mean, there's no reason not to, because they need to be changed anyway. Hell, you know, damn it, let's just, gosh dang it. We'll do the we'll do the voltage regulator, the flyback, and a cap kit, and then we'll see what happens when I power it on. I'm not going to turn it on the way that it is now, so I don't know what's going on with this. We'll just leave it. I'm not going to worry about it. I skipped that one because it's on the ground plane and it's going to not heat up with just the heat from the desoldering gun. It won't heat up enough. So in that instance, we take our soldering iron and get it hot with the soldering iron because of more surface area. And then we'll put this on here and suck it up. And it works like a charm. There you go. I keep knocking stuff on the floor here. And I have no idea what that was, so. So if you look here, all our holes are open. It's kind of hard to see, but it should just fall right out. So I'm gonna have to figure out what it is I dropped on the floor here. Oh, it's my Sharpie. All right, so now we need to get these screws out of here. This was in my way. Okay. Really? Gonna make me go to the side here? It's always a quarter. Okay. Alright, now it should come right out with a little crystal blue persuasion. There we go, just as easy as that. Now let's test it out of circuit, see if it still shows the same thing. One and 4. Uh-oh. So that's actually it's probably good. Well, I'll tell you what. Something's pulling that down. I don't think that shouldn't be that low in circuit. So what I'll do is I'm going to actually leave this out and I'll install the new one. And yeah, you can see all the holes were just nice and open. That's why it came out so good. So I'm going to go ahead and just put a new one in just for the hell of it. And there we go. I'm not used to it reading 1 or 0.1 in the circuit, 0.14, whatever it was. It shouldn't be that low. It should read, 0.5 something in circuit. But it's also reading across the resistor. So I don't know. I don't think that's correct. But anyway, got a new one installed. Let's solder it in. Where's my, there we are. Alright, probably all off camera there. My camera work is shit, I'm sorry guys. So we'll zoom back out and let's test this again real quick one last time. It's probably going to read the same thing. Yeah, same thing. So the other one's probably okay. I don't think it doesn't seem normal to me. I don't remember it being like that. I remember it being a better reading than that, more close to the diode. I mean, I could be wrong. We can test that theory by removing the wire off the B+ and seeing if it does indeed change. I think my theory is at the moment that it's actually reading across the resistor, and that's why it reads 1.5 and not what it's supposed to. Now that that's off of there, let's check it again. Huh, that's odd. Why is it reading? Oh, because it's upside down. I have to go this way. There we go. Yep. I had it upside down, so I had my leads reversed. Huh. I think I'm a dumbass. I'm about to prove it. Alright, that's back in. Now I'll bet you it reads the 1.4 again. There we go, 0.15. Now through the magic of being on the correct pins, let's see what happens now. Oh, no, still the same. It's because it's reading across, it's definitely now reading across the resistors, so that was a bust. I'm sorry, but for some reason I was thinking it was supposed to read the 0.5 in the circuit, not the 0.1, but it makes sense because you're reading across the resistor. I brain farted that for some reason. I don't know why. I don't know. I have no answer. Anyway, let's move on. So it looks like I can't find anything wrong that would keep it from powering on. Everything that would normally cause it to not power on seems to be okay. So let's do a flyback. Let's do a cap kit. The voltage regulator was okay. So the only thing that could be is either a bad cap, a bad solder joint, or bad cold solder joint, bad solder joint, lifted pad, something, or a bad flyback. Yeah. So let's go ahead and do our full cap kit, and we'll change our flyback out, and then we'll fire it up and see what we get. Of course, I'll do all the necessary reflow and all that stuff too. So, like, you got this whole area that's very common to be burned up on the K7000. You can see here that, this is burned up. That's all this. These pads are burned up, so these get very oxidized and don't work so well sometimes. Iffy joints like that are barely have any solder at all on them. Let's look around here again. This is very common as well. This one right here, very oxidized from the heat. It's a resistor across there. I think it goes from here to here is a resistor that burns up. And if we turn this around, yeah, it's this one right here, R101. So that's very common as well. So let's do our reflow, our cap kit, and our flyback, and then we'll see where we're at. I mean, I can do a time lapse, but everybody always just skips past the time lapse. I can tell you from experience watching people do time, I just skip right past it. So I don't think I'll do a time lapse. I'll just cut away here and come back, and I'll get all the caps replaced and the flyback and a good reflow, and then we'll show you how it turns out afterward. So, yep, with that being said, I'll get right to it and we'll see what happens. One moment. Well, and just like that, all done. Full cap kit installed. I cleaned up all of the back as best as I could. I did the reflow and everything that needed it. And by reflow, again, of course, I mean remove the old solder, put new solder on, cleaned up as best as I could the areas. And sometimes, you know, these pads are so oxidized that you have no choice but to scrape off some of the solder mask and fold the component over and solder to the actual trace. And I had to do something similar here because this pad was so, after I took the old solder off, the pad was so oxidized that it would not take solder. So I had to, scraping it away did nothing. The pad was just a lost cause. So I just soldered over to the next component, or the bridge over to the next pad on the same trace. But everything turned out okay. I didn't see any anomalies or any lifted pads or broken traces or anything. Yeah, so it's cleaned up as best as I can do for now. I might go back over again. You know, of course, there's so much flux on here, you end up just spreading the flux around, even with the alcohol. So it takes 4 or 5 multiple times to really get it clean. So I'll do that later. It's clean enough for now for testing. But like I say, full cap kit, every single cap, new flyback. And of course, these come, the brand new ones come with the screen pod turned all the way down. So you have to actually turn it up a bit. Let's see, it's all the way down now. So let's, yeah, it's all the way down. Let's turn it up. I'll turn it up about there. Okay, we'll see what that does. I got the ground connected to the frame because that wasn't hooked up. I got my DAG ground wire that was broken off. I got that hooked up. Everything else is connected. I did the solder and heat shrink for the new connector here for the new G2 wire. The focus wire is hooked up. The thicker wire is always the focus wire, and the thinner wire is always a G2 wire. I say always, but I've never seen one that wasn't that way. And all the pots are good. Visually, I checked them. I didn't check them electrically, but visually they're good. I set all of the color pots to center, which is something I always do, just to make sure we have decent color. And the neck board actually looked okay, and there's no caps on it, so everything checked out. Nothing was wrong. I mean, you saw before, the only suspect item was the voltage regulator, and that was my fault. I thought it was supposed to read 0.5 in circuit, but it actually reads 1.15 because it's reading through the resistor here. We learned that the hard way. For some reason my brain farted on that, and I don't know why. Anyway, I'm getting old. So yeah, I think everything's ready. Everything's been inspected. I didn't find anything wrong, so it's ready to power up. Again, it was labeled as believe X-Men playing blind 4-player. Well, so it was apparently playing blind, so I can only assume, since everything else was okay, that the flyback was going out, or either went out because it was cracked and it was a white knob. I'm sure the flyback died, but it's very, very, very unusual for a flyback to die and not crack and arc and take out something else. But everything checked good, so let's get it on the tube and we'll see what happens here. I'll pause here and I'll get the camera on the tripod, and then we'll hook up. I just touching this now, I noticed that it's higher. This one here is higher than the rest of them. You can see that somebody reflowed these pins and must have either replaced it or oh, my iron's off. Well, that's okay. I'm not going to worry about it. All right, I'll fix it later, I guess. But let's get the camera on the tripod, get it set up, and well, fingers crossed, let's see if it fires up. One moment. Okay. Oop. Drop that. I don't have a proper tray on this tube, so we'll have to just take some insulation material and put it on here. Alright. I don't know, because this was a U5000 tube, the yoke connector is broken into 2 places, so I don't know which way it's going to end up needing to be. But we'll hook it up the way it normally should be to start off here. Alright, yoke's hooked up. Set this in place. And you don't need it hooked up, but I'm going to hook up the degaussing cable. We'll hook up our anode. Okay, that's incorrectly. We'll hook up our neck board, and we'll hook up our DAG ground. And let's put a cap on here. All right. Okay, let's count. We got our anode hooked up, we got our neck board hooked up, we got our yoke connection hooked up, we got our ground hooked up, and we need to hook up our video. That should be everything. Anode, neck, yoke, ground, and then video. So, for this chassis anyway. Alright. Okay. Is that in frame? Yeah, not too bad. Alright, let's get our test pattern generator plugged in. Alright. And we'll turn it on standard res and turn it on. Let's get our power hooked up. There we go. Okay. Well, what do you think? Is it going to work? I can't say. Let's find out. Oh, hang on. Move that back over. Interesting. All right. So, okay. I think we're ready. 1, 2, 3. How about that? I don't know if you could hear it, but it fired right up. Let's see what it does here. Oh, that's not good. Let's do vertical hold. There we go. That's good. That is... Why is the green so much wider than the blue and the red? Something is not right there. But like I say, this has so many of these mods. I don't know what the hell these mods are doing. Maybe it's just super wide. But let's adjust our focus here. That's not bad there. Brightness. Right there's good. Contrast. Right about there. So that's a good image. It's just, for some reason, the middle is squished. Or not squished, wider than it should be. Let's do H position. Whoa, what the hell? Huh. Well, that's, the middle is the same here. Each one of these squares is the same. Why on the RGB is it wider? Huh. Let's hook up an actual board. Let's do MK1 here. These test pattern generators are good and all, but I always prefer an actual board when possible. All right. So here's MK1. Let's see what this does here. Oh, gee, holy shit, that's wide. Good God. It's upside down, which ain't a big deal. But holy shit, that's wide. That's huge. Hang on, hang on. We're going to do something about this here. Let's, first we have to flip our horizontal. I'm sorry, our vertical. Let's disconnect that. Disconnect that. Flip this around. And swap our vertical around here. Okay, interesting. I got a feeling though that I'm not going to be able to bring this in, so get yourself one of these tools if you can. It goes inside the horizontal width coil and you can turn it, and it's plastic and it won't damage your coil, and it's much easier too. Someone's got this maxed out where it's all the way driven up, which is wide. I'm going to drive it all the way down to where it's less narrow, or it's more narrow, and just kind of see what that does. I've never seen an image so wide, but it's got two. Remember, it's got two in parallel, those caps for a C38. I may take one of those out and just leave the one in there, because this is crazy. I've never seen anything like this before. That is super wide. Okay, I drove down the horizontal width coil as far down as it can go. Let's see what that does. Usually all the way down is shrink, and all the way up is horizontal, or is wide. So let's plug our video cable back in, and our power. There we go. Okay, let's see if that does anything. It's better, but still, if I was to center the image, each position, yeah, if I was to center it, that's not even centered. Dear Lord. Holy cow, where's my vertical size? So vertical's okay, but oh my God. So what we'll do here is I'm going to take one of those caps out, the poly caps for C38, and take it out of there, because I don't know how this was even working. Unless they have this on a tube that is not compatible, it shouldn't be this way. So let me take one of those caps out, and then we'll see what happens here. Okay, so instead of actually removing one of the caps, it was going to be easier for me to cut one of the legs. So there were two width caps in parallel attached to C38 in that location. I just cut one of the legs of one of the two, and so now it should just be the single one in circuit. Let's see what that does. Well, it didn't like that. It didn't like that at all. Oh, well, let's do some more tinkering, see what I can figure out. Oh, man. Let me tell you, this thing basically zapped my will to live. If all the rest of these chassis are this troublesome, I'm in for a world of hurt. So I got this fixed, but not without extreme duress on my part. So we saw before, the chassis was working, but it was extremely way wide, unbelievably wide. And so the very first thing I did was, because this is not normally on here that I've really ever seen or recall, you know, I think maybe in the fogginess of the back of my head, I remember seeing something like this on other ones in the past, but it's been so long since I've seen one on here, it looked odd to me. So I took this off. And when I did that, it indeed shrunk the image. But I had about 3 inches of black on the left and 3 inches of black on the right. And I had the width coil driven all the way basically out, and it moved a little bit, but I still had, you know, 2.75 inches of black on each side. Now the problem with that was the edges of the image were squished. So I had a full image, but along the left side and along the right side it was squished. The I don't know, ½ inch on each side was squished in. kind of like when you have vertical problems with the 50-60 hertz pot, where it folds over on itself or squishes on the bottom or top, and you have to adjust this to make it not be like that. It was kind of like that on the sides. The sides were squished in. So, you know, I was very highly suspicious of this stupid thing. So you saw there when I cut one of these out and just left one in circuit, like this was in there, and I just cut one of the legs. And when I did that, the chassis didn't fire up. It was not happy. So that's where we left the video at. So I put it back together, or soldered it back together with it still in circuit, with this removed, and that's when I had the image where it had 3 inches of black and the corners, the edges of the screen were squished in. So I was highly suspicious of this monstrosity. I've never seen anything like coupling two of these together. And trying one individually, the chassis wouldn't fire up. So I don't know what's going on with these things. So I just took the correct rating and type of cap out of my monitor width. I have a width cap kit here. So I took the only one I have left that's the correct size and rating. And I put it in there, and it fixed the problem of the image being squished on the corners. I still had the 3 inches of black on each side, and no amount of adjustment on this would make it go any wider than that, maybe, you know, 2.75. So I still had the issue of the 3 inches of black on each side, and I couldn't adjust it out. So, but this, replacing these, fixed the issue of the squishy corners, squishy sides. So now I had a full, complete image, and it looked perfect, except I had 3 inches of black on each side. So I thought, okay, so I just put this back in. Obviously this was serving some type of purpose, so I put this back in circuit, and boom, I had a perfect full image, correct and everything. So that fixed the super wide image. This, replacing the width cap with the correct type, and getting rid of this stupid thing, and putting this back in circuit, fixed my width. So now the width is, I can adjust it up and down, and it goes full screen, a little off screen, a little past full screen. It's perfect. But I still had a vertical problem. The bottom of the screen now that I had a full image, the bottom of the screen was squished, just like the sides. And I tried to adjust the 50-60 hertz pot. It did not work. It had a very tiny collapse issue on the bottom of the screen. So if you remember, if you go back and look earlier in the video, there was this resistor, this coupled resistor here. There you go. This device here was installed, I think it was, yeah, it was installed across here, from this point to this point. This thing was here like that. And it shouldn't have been, because this resistor was installed on the top side. In this location here, R82, it's supposed to be like 370 ohms or so, and it's right here in the vertical circuit. It's supposed to be 370 ohms. I was suspicious of this setup as well, so I measured this on a good chassis, and this resistor in R82 is supposed to be 380 ohms, give or take. While on this setup, with this installed, it was 7.2 ohms. So I don't know what someone was thinking with that. I don't know if they're trying to use this on a 27-inch tube or what. I can't say. I have no information other than it was in a X-Men 4-player, and those are only 25-inch. So I took this out of here, and I put a 380 ohm resistor in from a donor chassis, and that fixed my vertical squish at the bottom. So I don't understand. Oh, I also took this out. There's another capacitor here that was sitting like I believe it was like this. I took this. I don't know what this is for. It shouldn't have been there. I took that out too. That's normal. So I left that in there. But so now you can see it's much different here on the bottom than how it used to be. All this other junk here is gone. This capacitor here was in this location back here, and I suspected this as being bad, so I replaced it, but it didn't really do much. So yeah, after capping this and doing the flyback and the reflow and everything that needs done to these, as well as getting rid of this and putting the correct width cap in, and getting rid of this vertical mod here that someone did that shrunk the bottom of the image, now I have a full, complete, perfect working image and a full, complete working K7000. So, oh, I forgot that I also broke in my troubleshooting adventures. A wire got hooked on the whole pot and it broke it, so I had to replace it with a different kind, but it's the same rating. So, but yes, that should be everything. So let's get it on the tube and check it out. So I also replaced this. This was supposed to be 3.9K, but it was 3.7K. So I replaced it, and this one's 3.9. So this was slightly out of spec. So I changed this one anyway, thinking this might have been the issue, but it's not. The entire problem with everything that I had was this thing causing the squished sides, and this causing the squished bottom. So yep, now it's working. Everything is resecured and cleaned up, and well, not completely cleaned up, but cleaned up enough. And there's supposed to be a, I don't know what mod it is, but one of these chassis, there's a certain mod revision where they put this capacitor across the first two legs of, what is it, IC1, yeah. So I went ahead and did that just because there's no reason not to. So that's something else if you notice that between the first part and now. So this resistor here, somewhat normal. Then there's this resistor here is actually supposed to be right here. So if you look here, there's supposed to be a resistor in this spot. You can see it right here. It's missing. They've put it on the bottom side of the board, just like they did with D18. But I fixed, remember D18 used to be across here, and I fixed it. I put it back where it's supposed to be. You can see it in there, right there. So I fixed that. So now it's not so butchered on the bottom side. This diode here, I don't know what purpose it's serving. Obviously someone put it there for a reason. I don't want to take it out because if I take it out and it's supposed to be there, I don't know if someone's done something else or put the wrong component. Couldn't find anything. But in case someone did something that caused this to need this diode, I don't want to take it out and possibly damage something. So I just left that diode in. That's the only component. I should say this one and this one are the only two components I left in from the somewhat butchery of this. Everything else is all removed here. So yeah, let's get it on the tube and we'll test it. I'll show you that it's working, and we'll move on to the second chassis. This was just, man, I tell you, I spent like 6-7 hours last night trying to figure this out. And oh, and I also installed the jumper selector here. I mean, it doesn't really need it when, like I said, when you're hooked up to the middle selection, it's just a dummy connection. It only actually does anything if you move it to left or right to center the image. So, but you really don't even need this unless your horizontal position won't move it all the way to one side or the other. You can use this to offset it. But just for the sake of having it complete, I put that in there from a donor chassis as well. So, all right, let's see what we get here. All right. Okay, let me get on the tripod and we'll see what we get, how it turns out. Okay. All right. Okay, insulated. Oh, I forgot to mention also that I soldered the wire on here a lot better and then put a little zip tie for strain relief to keep it from breaking off again. So now it strains on the zip tie and not the actual solder connection. So that's for the DAG ground, of course. It's always a good idea to do that. Okay. Damn it, I broke the back. Well, that's okay. I'll figure something out here. I broke the little protector. That's okay. Alright, let's get our ground hooked up. Just put this on here real quick. Alright, so we have anode, neck, yoke, ground. Okay, where's my power? Okay, and we'll start with the MK1 board, then we can go back to our test pattern generator. Okay, here we go. And I've already had this tested. Hey, what's up? Already had this tested, so I know I already have the screen position and size and everything done, so let's see how it looks. Okay, came to life. Let's back up here a bit. there you go. Perfect. So, yep, wrong caps and wrong resistors, and I don't know what else this thing was going on. What was going on with this? So, but yep, as you can see, it's now a full image with no linearity problems or anything like that. So, oh man, I tell you, this was a tough one. Every so often you get the ones where you can't just replace, oh, the HOT's blown, replace the HOT and it fires up and you go about your business. Every so often you get these ones that someone's really done some hacks to. And if the label is correct and it really goes in a 25-inch 4-player X-Men, then this will be absolutely perfect now. If they're trying to put this on a 27-inch tube or some other type of cabinet, if it's not dedicated, if it's 27-inch or something like that, then they'll have to put those mods back in. Or likely, I would just leave it like this, and they're going to have a black border around the screen. But as you can see right now, on a 25-inch tube, the way it's supposed to be set up, it's perfect. So I'll call this repaired. I'll leave it run for an hour or two just to make sure, and then yep, I'll call it fixed, and we'll move on to number 2. So hopefully you learned something. I know I did. So stay tuned for number 2, and we'll see how that turns out.